everyone, this is the Math and Science Group Content Literacy Project. I'm Meg, and I'm going to talk about group projects in the math classroom and how they can be used to have new literacy strategies. So I read an article called, "When Will I Ever Use This Stuff Anyway?" And it was actually a college level class, and they were trying to learn about ways that mathematics was used in the real world. So the teacher assigned everyone small groups, and they went out and they found a mentor to interview who owned a small business. And they interviewed the mentor about how they actually used algebra in their job in everyday life. After they conducted the interview, they made a 10 to 15 minute presentation and gave it to the class. And then they took this presentation and worked with the teacher to kind of perfect it so that they could go to the local middle school and they could present it to the middle schoolers and they could learn something about math in the real world. So in the article, they talked about a lot of things that the students learned by completing this kind of project. It promoted self-discovery, collaborative learning, exploration of career opportunities, application of knowledge, and service to the community since they actually went and visited a middle school. But I started to think of it from a literacy standpoint. And, the students, they were writing interview questions. They had to actually go conduct an interview, which connects to a lot of the speaking and listening standards, which I'm going to talk more about later. And then they presented their findings and even went back and revised and edited and talked about how they could make their presentation better. So how did this actually pan out when they did it in the classroom? Throughout this whole process, the professor surveyed the students, the mentor, the middle school, and kind of asked them what their feelings were about every step of the way. And the information that she got back was that the students really appreciated that this was a look at mathematics outside of the textbook. And 100% of them said that this project helped them to learn. There were some challenges because there's a lot of math content that needs to be covered, and it was kind of hard to fit in such a huge project into the semester. But the teacher also commented that with that being a challenge, it was well worth it to take the time out and do this kind of project. And another challenge was that there were so many people involved that it was hard to coordinate schedules with the mentors, with the middle school, with the students outside of class. But everyone involved was happy with the outcome. So same thing was kind of worth the challenge. So here I have some literacy standards from the English Language Arts Common Core. And these were just the standards that I thought connected really well with this kind of project. The first one is about collaborative discussions. So during this project, the students had collaborative discussions within their small groups, with the teacher when they revised their presentations, with the mentor, and then with the same thing with the mentor when they were interviewing them. That connects to the second standard, evaluate a speaker's point of view. So that was, the listening standard tied in when they actually conducted the interview. And then finally, this last standard is about presenting. So that was kind of the big thing at the end was the presentation. So then I just thought about this article and this project that they had the students complete, and I thought about how we could tie in even more literacy. So the first thing I thought was having the students actually read something. So they could read a text before they conducted the interview to kind of give them ideas about math in the real world. They could read a text after the interview to further their research. And this would also be helpful because the students said that they really liked getting away from the textbook. So this would be a text outside of the textbook that the students could look at. Also, just not even doing a huge project like this, the students really appreciated not using the textbook. So you could do a text just, hey, read this text. It's not the textbook. You can learn something different without the whole big project because it wouldn't be so much of a time commitment, and that would take away that challenge of fitting it in when you have so much math content to cover. And now Melanie is going to talk about group projects in the science classroom.
Okay, so my article was Talk Like a Scientist, and it talked about having science symposiums in the classroom. And a symposium is when you have a conference of people who talk about new research and ideas. The symposiums in the classroom could be done individually or in small groups of 2 to 4. The teacher would decide on a main topic, and then student groups would pick a subtopic within that category. Some examples are for biology, you could have endangered species or some rare genetic disorders. If you had environmental science class, you could do green energy. Students prepared a symposium paper and a short presentation that they could share with the other students after they became the class experts on their subtopic. So how the science symposium was implemented into the classroom. First, as I said, the students would choose a subtopic under the main theme, and then they would conduct research in and outside of the classroom. So they might go to the media center for a day and look up articles there or use the books available, and they would also do some research outside of the classroom. The teacher guided the students' research with a handout and advice on how to find reliable texts. The students would then prepare a symposium paper, which was a 1 to 2 page, short, easy to read handout that they could give to the other students about their topic. And they prepared a presentation that was a 3 to 5 minute talk without the aid of a PowerPoint or any type of poster, so that it was just informal and they could talk to the rest of the class. And the talk was given to the class as a whole. So why use a symposium? In science, scientists actually do something like this rather often to talk about new research and findings within their fields. There are different ways to hold symposiums, but the results generally are the same. You could have a PowerPoint and a poster as part of the presentation. As I said in this article, the teacher discouraged that, but I've seen symposiums where they had PowerPoints or posters and it went really well. Also, instead of presenting to the class as a whole, you could have groups of, say, 4 and 2 people could present at the poster while the other 2 in the group go around and look at other people's posters. Either way, or however you choose to do a symposium, the results are generally the same. It encourages students to learn by inquiry because they come up with a topic. It introduces students to scientific research and different texts, which is good because they get to use something outside of the textbook. And it promotes discussions about science. Content and critical literacy can both be improved through science symposiums. Content literacy, students are required to use various texts outside of just the textbook to find information on their topic. So learning how to research, look for articles, make sure the articles or texts you're using are actually reliable. And students also need to understand this information to put it into their own words and make sure that they aren't plagiarizing. For critical literacy, students are encouraged to look beyond the facts and think about how their topics impact society. In the article, the teacher mentions wanting students to include the societal impact in their handout so that the other students could see why their topic was relevant. And students could also be asked to come up with possible solutions to the problems presented. To make it more meaningful, there are a number of things that teachers could do. Before deciding on a major theme, they could ask students for their interests and try to pick a main topic that incorporated a lot of their interests. Students could also be allowed to invite family, friends, or community members to see the symposium and so they could share their work. And as mentioned in Talk Like a Scientist, the symposium papers could be collected and made into a book. So that was the first topic. Now Joya is going to talk about the second topic.
So I will be speaking about writing in the mathematics classroom. In almost every school, students use their writing skills in language arts, science, and social studies classes. However, an observer is less likely to see students writing in mathematics class. The principles and standards for school mathematics recommend students be able to accomplish the following for instructional programs: organize and consolidate their mathematical thinking through communication, communicate their mathematical thinking coherently and clearly to others, analyze and evaluate the mathematical thinking and strategies of others, use the language of mathematics to express mathematical ideas precisely. The standard is the basis for implementing learning logs. The purpose of learning logs is to have students reflect on what they are learning and learn while they are reflecting on what they are learning. It's not a polished piece of writing that's submitted over and over again, but rather it's an opportunity for learners to communicate ideas and to clearly refine and consolidate their thinking. It also allows responding to specific topics in learning logs. For students, they're encouraged to address the teacher's concerns. And learning logs are not time-consuming, but they are tremendously valuable. When mathematics teachers use learning logs, they can be confident that they are not taking time away from the content and instruction because students are using the time to write about mathematical concepts, algorithms, and problem solving. Some tips to help make learning logs an integral part of instruction. Students should use learning logs frequently, not necessarily every day, but 2 or 3 times a week can help keep the students in the habit of thinking about mathematics. Teachers should anticipate mild resistance at first. Teachers should write with the students. Doing so sends a powerful message that the teacher values the process enough to take part in it too. The teacher should not accept partial, ill-conceived, no-effort answers. Learning logs do not have to take much class time or much grading time. They can be read quickly to get an idea of how the day's lessons went. They can be collected and read at the end of the day, and they can be placed in the students' writing section of their notebooks. Students need to know that their learning logs are being read. Teachers should make sure they respond positively so that the students obtain more positive connections with mathematics. Teachers can use the information from students' learning logs to reinforce the connectedness of mathematics and the need for students to remember and use information from one unit to the next and from one year to the next. Reading an entire class set of learning logs lets us know whether the entire class or just one particular student does not clearly understand. When teachers read these learning logs, they get a picture of the student's understanding of a specific mathematical concept and can then modify instruction for the class period on the basis of students' responses. There are some benefits of learning logs. It's a type of communication that gives students the opportunity to think through problems, formulate explanations, try out new vocabulary or notation, experiment with forms of argumentation, justify conjectures, critique justifications, and reflect their own understanding and on the understanding of others. The primary benefit of the learning log is to the learner. However, it also allows teachers to understand students' thinking, communicate individually, and reevaluate instruction. And now Zach will be speaking about writing in the science classroom.
Okay, so I'm Zach, and I'm going to be talking about reading and writing in the science classroom. The article I read was titled Literacy in Science, a Natural Fit. And the writer of this article was a teacher that had a freshman class of science students. And one of the problems that she noted was that these students were coming in as freshmen with below 6th grade reading level. And that made it a problem for her because she didn't know how to present specific forms of text to them in a way that they would think is interesting or in a way that they could comprehend. So she noted this actually occurred with other teachers in her own school and decided to do a little research on the topic and figure out what are different ways that I can implement different strategies into the classroom to make my readers understand the material more. So the author tried to do this through an inquiry-driven approach, and by inquiry-driven, we mean that we try to focus on what evidence and what ways can we interpret different things like the data, figures, charts, and the information in the text in order to reinforce knowledge of the subject in our mind. One of the ways that she decided to do this was through having students record their thoughts in reading logs about each text that they would read for the class. On the sides of the writings or in a journal, per se, she didn't exactly assign a specific format, but they would write questions, short summaries of the text, or personal connections to the learning material that the students might have. This caused them to think about what they were reading more so than just trying to get the facts and move on, and actually just take time, and try to put things in their own words. So besides just using the typical science textbook, the author tried to think of different ways and activities that she could implement different sorts of texts into the class. So the first one that she mentioned was science in the news, where students would look at news articles that had subjects that were related to the current topics in the class. And they would present them to the class and just give them a short summary about what the article was about and what they should take away from it. Another cool thing that they did was that the students would read in the textbook about a certain subject that they would want to write about, and they would write a children's book based on the information of that subject. This accomplished a couple of things. It allowed students to have a creative activity where it wasn't just set in stone, you're just writing a plain old essay. You get to write a children's book, which is pretty fun. You can do a little illustrations with it. But one of the cool concepts about it is that by writing a children's book about it, you have to think of how you're presenting this material to a child. So you have to break down what you're reading to its most fundamental aspects. And if you can communicate the basics to a child in a way that they can interpret and understand, then you have a better understanding of the subject yourself. The third thing that she mentioned was an interactive historical vignette that students could perform. This would require students to do research on scientists, and they would dress up as these scientists in addition to writing a short presentation and talk about their contributions to science as well as their personal history, and then have questions from the class that they would answer in the form of the scientist. For example, I could come in dressed as Gregor Mendel and talk about the history of genetics and my contributions to the science. And the last thing that she mentioned was that students can participate in a science book club. These book clubs could be organized by different levels of reading, where lower levels of reading would be focused on maybe like young adult texts, where the material isn't that difficult to read and understand, whereas a higher order science book club, a group could be reading something. I think the example that she gave was from Michael Crichton. Michael Crichton is an author that regularly implements real-world science into his texts, such as Jurassic Park or Prey. And those are both novels that a book club might read that would allow them to talk about something they're learning in class, but also have it be an entertaining book at the same time. So some important lessons and takeaways from this. This inquiry-driven approach that used non-textbook activities for the students was actually successful. She did perform this for 2 years of students. So important things to take away from it is that you want to allow students to devote research to topics that interest them. These students were talking about things that they decided that they wanted to talk about. It wasn't just assigned. So when they thought about, oh, what scientists do I want to present on, they were thinking about, well, what subjects am I interested in? You want to be able to challenge students with gradually more difficult text. One of the beginning issues was that the students weren't really understanding the text that they were supposed to be reading coming into the class. So by gradually giving them more and more difficult texts for them to comprehend and understand, then that way, at the end of the course, they'll be at a higher reading level than where they began, and they'll be able to transfer these skills into future classes. Another thing is that you should encourage group work and promote creativity and individuality. Students learn a lot more when they're being creative and sharing their thoughts with other students, because it allows them to see points that they didn't think of themselves. And some final things to consider. While these activities are great to implement into the classroom, you can't ignore the importance of learning content in the science classroom. Otherwise, students won't be able to present well. So you need to have a balance of these types of activities, but also focus on the learning material. Depending on your grade of teaching, you can adjust the level of complexity in text. Say, instead of a freshman, you're teaching a senior class, you could try to implement like scientific journals maybe into the teaching. You can encourage students to read scientific texts that have general interest, and you can consider implementation of social media, like having a Twitter account for your class where students can propose ideas and news articles, whatever you want, to other students in the class, just to show that they're interested in what they're learning. Okay, so that's all we have for you. Thank you for